Let's solve this random problem from CodeCheff, which is named a video game. So I will be solving this in our editor local, and we'll try it on actually after that we'll paste it over here. So here's it. Because we need to set up the Python interpreter. Let's get out. So first understand the problem. What is it? So before it is Journal Computing 2004. Okay, that is the problem. So you are playing. First, let's understand. You are given a use case scenario. You are given a requirement, uh, or a feature or bug. You're solving. First, you need to understand that scenario. So, what scenario it is? You are playing a video game in which several stacks of boxes are lined up on the floor with a crane on top to arrange the boxes as shown in picture. So it is simple. Several boxes are lined up on the floor. Okay? They are on the floor. And we have crane over here on the top. So with a crane on the top to rearrange the boxes as shown in picture. So we have this crane. So using that, we have to rearrange the boxes. We have the crane and the several boxes are here. So that is the actually starting. A crane support following commands. This crane has a following commands. So think of now you are so what are those commands? Move arm position left. Does nothing if already almost carefully read through. Move one position left. Does nothing if already at the leftmost position. So you have the crane, so you can move it left. And if it is actually leftmost position, it does nothing. Move one position right and does nothing if it is already actually rightmost position. Pick up the box from the current stack and does nothing if the crane is already has the box. Okay, so drop a box, drop the box, yeah, on the current stack. So it does nothing if the crane doesn't already have the box. It means it can't actually drop the box if it is not having the box. It is not holding on to any box. So further, there is a limit h on the number of boxes on each stack. So if drop command would result in a stack having more than h boxes. The crane ignores the drop command. Okay, it is like for suppose if stack is having should have only at most 4, and which is h means just in place of h consider 4. If we issue a command, drop command would result in stack having more boxes. So it means it is going to have more boxes than a 4. The crane ignores the drop command. Okay, so it doesn't do anything. If the current stack has no boxes, pickup command is ignored, which means that can't pick up anything, right? So you are given initial number of boxes in each stack, the sequence of operation performed by the crane. So you have to compute the final number of boxes in each stack, which means that after we perform these operations, you have to compute final number of boxes in each stack. Got it? So after performing all those operations, we have to, that is what we do. So what is the input? You are given initial number of boxes in each stack. So we are given those, what are the boxes in each column or in each stack. So for example, suppose this is just an example, we know that, they are we are given some test run. For example, suppose the initial configuration of a game is as shown in the figure above with the 7 stacks. Do we have 7? 1, 2, 3, 4, 5, 6, 7. 7 stacks, right? So one stack is empty here. So 7 stacks. For example, suppose initial configuration of the game as shown in the figure above with the 7 stacks and h is 4, which means that we can't have more than 4. So if for suppose we issue a command to drop a box here, it is ignored because it is going to be having a more than h, more than number of 4 boxes. So then after the following a sequence of instruction, then after the following, so these are the sequence of instructions that are given. Number of boxes in each stack are left to the right would be. So if this sequence of instructions are followed, it would result in following boxes from left to right. Okay, so pickup, it is where it is leftmost. Okay, if it picks this leftmost one, for leftmost, so we would be having a 2 only, right? Okay, so I'm like that. So let's check this in. What is how input format? The width of the game, which means number of stacks, n, followed by the maximum height of each stack. So it takes 2 inputs, and line to number of integers, the initial number of boxes in each stack from left to right. Okay, which should be less than h. Okay, so we just enter something like this, initial number of stacks. Okay, and so after that, there is this one. Okay, so each sequence of integers, each encoding a command to a crane. The following commands are encoded. So 1 means move left, 2 means move right, 3 means pick up, and 4 means drop. We give these inputs, these commands. Okay, and after that, after the commands, okay, so 0 means quit, appears exactly once. Okay, last command. So initial position of the crane above is leftmost stack, and with the crane not holding any box. So if you run this thing, the sample input for this scenario, check this sample input for this scenario, okay, and sample output. So which is the 7, right? Number of stacks 7, the number of h is 4, and the sequence of operations, can you see 3 means what? 3 means pickup. You can see here it is a pickup. Okay, and so where is this one? 1 means 1 2. Next command, sir. What is 1 is actually move left and 2 is move right. And you can see here the move right. Hmm? Move right, move right. Why? Because and sorry, my bad here. This is actually second input is a stacks. So second line and the n integer initial number of boxes in stack. Second line actually denotes number of boxes in stack. You can see here 3 1 2 1. Yeah, 3 1 2 1 4. Yeah, sorry, my bad. So and the third one is a sequence of commands. You can see here 3 pickup and 2 2 2. You can see here the pickup move right, move right, move right. And after that sample output, what is the output after performing is all these operations? We have the result. It should be actually number of boxes in each stack. That is what we need to do. So coming here, so we are not. So let's solve this making use of functions. So I want one function first define get input, and I need to write a commands. Okay, so what I can do, so we want to use this. Okay, so we are not, there are some scenarios here, test data only, uh, there is only one subtask with 100 marks, we get actually awarded marks number of commands, and this is a here, and probably there is no actually time complexity here. And because we need to some for some problems we need to take care of time complexity, and where what is time complexity means number of how much time it takes. Okay, so how much time for your so writing your code efficient. So it defines amount of time taken for your algorithm, the approach you come up with. So some problems are, so they check so time complexity as well, so we're not considering that. So we're going to use let's say classes and the functions and to write in effective manner. So let's go back. So what do we need? We need an input. So what do we need? Crane. So we have actually what is called, yeah, so this is the problem we are solving this video. So this all instructions are for crane, right? So let's define a crane class. Okay, so let's write instructions for left. What are the instructions? Just I'm defining placeholder. So how you are approach? How do you want to approach? Move left, move right, pick up, yeah, drop the box. Make sure methods names are not, when you're naming, by naming convention, you don't we don't write method names first letter caps, because our uh, only class names start with caps, and the methods and functions should always start with a small case by convention. But nothing is stopping you, and you will not be uh, no error will be thrown at you even though if you name method with the caps uppercase first letter. But the problem is that we can't recognize. We will be mistaken looking at the method, which is a class. So move right and define move, pick up right, pick up, and drop. Yeah, drop the box. Drop. And there's an operation called quit. Yeah. So let's write a main function which will act as a main starting point, and if main equal to main, which means that we want to run this as a script. I call the main function. So this is a magic attribute. So which when you execute this file, yeah, and when you execute this file as a script, this name contains main. When you import this as a module instead of running it as script, name contains the file name, module name. So, and let's set up the Python interpreter. If I configure, we can add interpreter here. We can create a new environment inside our folder using Python 3, or else I can choose to actually go So, but I can move forward by providing existing environments if there are any. Creating a new one. This is a virtual environment. So virtual environment is helpful when you want to work with the when you are having conflicting dependencies across multiple projects. It creates a separate environment for your project only, so you can work without conflicting dependencies across multiple projects. So since I have configured, now I can run this thing. Just first thing, go lean. Okay, by lean. Okay, don't try to actually solve everything once. Okay, so that would be actually, so if you try to write a code or all code once and wait for a whole code to be finished to run, then you are actually, it means that more code means more errors. So go lean step by step, make sure it is working. Print hello. So we will remove these all of them when we actually, so it is working. You see, when I run it as a script, a main function is getting called and it is getting called. What should I do? I need to get the input first, right? So I need to call get input. So we will remove this print statement later. So what do we need to n? We need to take an h input of, yeah, input. I need to get the integer h. That should be integer, right? We are not doing any exception handling. We will do. So I got the n and integer, and then second, as you can see here, second line. Second line takes, if there is a n, it takes that n numbers. First line, if you see here, 7 is a n, h is a 4. So we will need to take actually 7 integers. Second line provides the initial number of boxes in each stack. So let me take for, okay, for I in n. Okay. So to store the stack, what do I need? Stack is like kind of sequence, right? This is actually helping you to think what kind of data structures you need to use here. Okay, so these are different numbers. This is just a variable here. Got it? I need to use range. Just a single number here, single number. But here I need to, so if you look at the example input, I need to store this stack of boxes, which is a sequence, right? I need to, what is matters here? What matters here? Yes, sequence also matters. Uh, right? Sequence means order. So what are different data types in Python? Different data types, we have integer, float, complex. Yes, integer, float, complex, and string. And we have a Boolean, tuple list, dictionary, set, frozen set. So these are different types of data types. Let me show it. Crane as an object which has some properties and methods. We wrote methods. You go further. We have data types here. Yeah, what data types here? Yeah, integer. So none, boolean, integer, float, string, tuple, list, dictionary, set, frozen. And these are actually, so data types can be classified as according to storage model, access model, update model. And scalar. These are scalar, non-boolean, integer, float. And so other, according to access model, direct sequence and mapping. So we need actually kind of sequence or a container to store to accommodate these multiple values. So if you know, just like these integer complex and integer complex and float, they are just scalar types. So they contain only single values. We need a containers or sequence. No, of course, strings are not containers, but they actually sequences. Okay, so sometimes non-containers can be a sequence types. So we want actually sequence types or container types. So sequence means that not necessarily in Python they are actually stored in contiguous manner in memory because it uses heap, not necessarily then sequence types or container types. Sequence types elements are stored in contiguous manner, so one after other. So but we tend to access them one after other. We can but scalar string, it actually may resemble the sequence type, but it is not. It is scalar type, but it actually offers the axis model. It supports what is called axis model, a sequence string, but it is a scalar type, not a container, and the axis model is sequence. So now when it comes to what are the sequence types we have here, so list and tuple. Okay, so what is a list? And you can see here the list, tuple, those are sequence types. And set, frozen set are not sequence type, they are sets. Okay? The order doesn't matter, they are actually uh, non-repeating elements they contain. So dictionary is a mapping type. So I should be using a tuple or list here in our problem. So tuple or list. So tuple is immutable. So if I add up actually anything, it doesn't actually modify. So since I have to, as I take the input, I need to add to the sequence. I am actually ended up with the choice stacks equal to a list. I defined the list. Now with the every input, what I will use, how do you append the element? How do you add element to the list? Using append method. So using the append, I'm taking the input. So let's take the input s equal to int of input. So how many times? So and I'm appending it to appending the s here. And I need to do it for how many times? Yeah, so probably if the input is 7 times. Okay, and however how much, whatever you add, whatever the n value is, and what is h value, which is h is necessarily number of elements per stack, number of per stack, number of boxes per stack. And what is second one is actually you give commands. So you see what is the last command is 0. Yeah, so until you encounter 0, you need to take the commands. Okay, so until you encounter 0, we need to take the commands. Okay, so probably what I'm taking, so let's take actually so here I'm taking this as an input, iterating over that, or else I can actually simply accept a sequence, okay, and split that. So do this, okay, for the first command. For this command, what I'm doing, I'm just iterating over the iterating over for a number of times and getting the input. For second one, what I will do, I'll just get the string commands equal to input. Okay, and just I'm getting a string. What I will do, commands input, let's call it a ci, and commands equal to, what I will do, I will split split by space. Okay, and what I will do, if I split by space, what I will get, so let's go to our interpreter and see. And we have actually, let's say, I'll copy this one. This is input. If I do x dot split, we get actually string of integers. What I can do, I can use a map command to convert all of them to integers. Oh, sorry. Yes. Okay, so this is how actually we can get those commands. So I'm expecting the whole line, so not multiple. Just like, we can do both ways. So in such a case, it takes a single line only, assuming that the input is always given in a single line. So to do so, map of int comma split, we have the commands. So all inputs we got, whatever we need, we got the inputs. So just to print, to make sure we got actually everything, print in different lines, n comma h, and print given inputs. I'll remove this. This is what go. Use a lean production, lean development. Go step by step, small improvements. So I wanted to take the inputs and verify if we are getting actually them. And print. Next one, tags. And next one actually print commands. Run this thing, getting input, so which is 7 comma 4. Okay, so we run this one, 7 4. Okay, and we get actual error. We, instead of actually looping over, okay, we get this error because this is taking this whole line as input. We're throwing it is throwing a error at us. So instead of doing in such a case, if I run, this is how we should. So suppose make it actually 3 comma 2, and I should be giving 2 1 1. Okay, and 2 3. You see here the output given inputs 3 2, and second one is a list, which is actually whatever we have given here, and third one is actually, since it is a generator or iterator, so we don't see here, so we can actually, if we convert it to the list, we would see. Okay, so instead of going this way, so let's actually do the split, because let's take the input this way only. Same thing. So here, instead of it would be stacks, and yes, I. Okay. Now, the first line, n comma h equal to what we can do, map this off. And what I'm doing here, list comprehension in input of, okay, then split. Let's see if it works. Run this one. 3 comma 2, and okay, so I'll stop this one because we wanted to print a list, convert them to the list. Okay, rerun this. 7 comma 4, copying this in my time. And you see, we are able to take the input properly, 7 4, and the inputs we have here. The second one, a series of commands. Okay, so we got everything. And next time when we get the input successfully, okay, and we need to initialize, let's do the crane thing. Okay, define so in the crane we have a special thing called initializer, right? So init method, it is a magic method. Okay, so we call it as, actually we also call it as a, it is also, some people call it as constructor. More than constructor, it is a initializer. So it is initializes the class. So we wanted to call, send this thing with the n comma h comma tags comma commands, so that we will have self dot h equal to h, self dot tag equal to stacks. I'm just initializing. These are instance attributes, not class attributes. Okay, so we can actually make this as a singleton, so we can do all of that, but let's make this simple. What do we want finally? Finally, we want output after performing operations. How many what are left actually in the stack? Okay, so current stack we are initializing, and the commands, we have commands. Define, I'm just actually do start. So with the commands, what I will be doing, I will start that, or what we can do, we can call something called call magic method. What call magic method does, you know, so we can actually simply call the instance as a function. Okay, so what it does, let's say that I have foo class foo, I have call magic method print getting called. So I equal to foo. So this when we call actually the class, what happens, you are creating instance. But when you have a call magic method, when you call instance, that call method will be called. Okay, this magic method will be called. What I'm doing, so to get the operations for the instance, I wrote a call magic method. So when I call after instantiation, so all operations will be executed, and we are left with stacks. So what I'm doing in each method, print the statement. We will remove all of them later. Moving left, print. Moving right, yeah, print. Pick up, okay, and then drop, print, quit. Okay, and so what we will do now, just add a print executing commands. Okay, now for command or cmd in self.commands. Okay, and we need some dictionary here for commands, or commands equal to, because commands are mapping, remember, types again. Come here, what is what type is actually, what is a mapping type? You see here, dictionary is a mapping type. Like it's like how do you define this? Using curly braces. Yes, and we contains items with key value pairs called as items, which means the key having the values, associated values. So we, how do you actually to fetch the values, get the values? He acts as an anchor. So what are the commands we have given here? Commands, see, that is a key. Using appropriate data structure is the key. So one is move left, and 2 is for move right, 3 is pick up, 4 is drop, and 0 is quit. So what I'm doing here, okay, so instead of actually, I don't want these commands because I don't want conflict between these commands and these commands. What is this? Command codes, let's call it as a command codes. Okay, so one is for move left, right? Yeah, what I can do, simply I can, for one, I can simply refer to this method. Okay, but there can be error. So we have, there can be error. Why? Because unresolved reference crane. Why? Because you know why? Because they can be unresolved because by the time, so this class is not defined yet, so we can't use that reference set. So we get this error. So what we can do, we can simply also use these names. Two for a move right, but use correct name. Move right. 3 for, yeah, pick up, yeah. 4 for, yes, drop, and 0 for quit. So when there is a quit, no longer actually nothing is performed. So we have some built-in functions, you know, right? Get attribute. And when you go to built-in functions, there are some functions work with objects and classes. So that are has attribute and a get attribute. See, get attribute. So using get attribute, what we can do, you can pass the object and the name. to get the attribute. So we are doing that only. So that is the reason we use the exact name. So that what we can do, we can simply we can do something like this. You see here, I write get attribute, and I can give I and then call the function name. Okay, so the you string, you can pass the any method name you wanted to get as a string. Okay, so what I did do, so I have mapped our functions, our method names to commands. So for command in commands, what I can do, I will be calling get attribute self comma self. Self refers to itself, right? That object itself. So and then command quotes, since command self dot command quotes, and all I need to access is give that cmd because it is an integer. So instead of doing that, so first what do? We print the commands, right? From command quotes, executing commands, what we will do, print commands and just give those numbers. Okay, and then what we will do, print, make sure we are able to self dot command quotes, we are able to actually decode those commands from numbers. Do you get it? From self dot command quotes, if one means what I will get, move left, right? Just let me show it to you again. Here, if I paste this thing, come on, I'm not able to paste it here properly. Okay, so wait a minute. I have IPython. This would help. Okay, so command quotes. You see command quotes of 0 or 1, what I will get, move left. Command code of 3, I'll get pickup. Okay, so and I'm printing this. Let's call this thing. We're not calling this function set. To execute this, run this, and where is our video game? Here it is. And here, so we haven't called this. Do you surprise, why nothing is getting executed? Because this is not getting called, right? Executing commands, we don't see that. Why? Why? Because we haven't called that. We haven't created any instance of crane, and we haven't actually called that instance. So do that. After getting input, let's return those inputs. Return n comma h comma stacks comma commands. So let's take them. So unpacking them here, packing them here, and we are unpacking it here. So we did the unpack. And create a instance crane, but I have to pass all of them. And if you create an instance, again, if I run this thing, nothing is happening. We are just getting inputs and just initializing, because I actually, for our sake, print creating or initializing it more than calling initializing crane. But on this thing, See there, initializing crane. But nothing, this is not getting called. What is this one? This call method, when it will be called, it is a magic method when we call the instance. So call the instance. Here you go. T, right? That is how you call the instance. Okay. CRN crane, CRN I called. So run this thing. If I run now, I can see here initializing crane, executing commands, and commands as a map. And so let's run this one again. What do you see here? Initializing crane, executing commands, and map object we have here. Okay. And this, I'm printing this self.command quotes command. So we have commands properly, right? Isn't it? Let's put this thing in a list. We can see. Now what happened? Why are we getting a list empty? Come on. So we need to print. We need to remove these. Why? Because this is most of the newcomers do these mistakes. This is a gotcha. This is like a what? So this will like kind of bite you. Takes kind of consumes a lot of your time to debug. So see here, and have a stack, have a commands, and if kind of after I received, I will print all of them. Print. Okay. Print n comma h comma list of stacks comma list of commands. Okay. The print received at init. And it is surprising to see, right? We will get stacks and commands empty. Why? Why? Why you have stacks empty and commands empty? So of course we are passing them. We are taking input. We are returning here them. We are returning them. We are actually, those are packed and these are unpacked here, and we are passing here. Why they are actually empty? Why? Because do you know generators and iterators? Let's say that I need to clear this. Let's restart this one. So let's say you have here generator. How generator work? Generator is actually a compact way to create iterator using function. So when you have a generator or iterator, suppose range of 10, what is this? Yeah, x equal to range of 10. Okay, so if I do list of x and walk X contains, you see it contains actually uh, yeah, so it is, we are getting here, let me write what is called generator gen for I in range of 10, yield I, and g equal to gen. So when you actually have a element, the yield in a function which actually returns a generator when you call, you see here, which is a, we have generator. So every time you call next and you get the next element every time. So this is stateful. Okay. So but once you actually reach, now if I use a list, remember, wait, you get the stop iteration. So let me create this one again, gen. So now I'm calling a next. You see here, I am able to get till 5. If I use list of g, I'm able to kelp because I'm not able to get from 0 because I consumed them already. Yeah, I consumed them already. So I get actually from the next point onwards because list is calling actually next for us implicitly. So now if I try to call next, because we consumed everything, there is nothing. If I try to get a list out of a generator again, we get the empty list. Okay, that is what happening here because we printed these two. Okay, you see it is kind of tricky, so you can be actually caught into this kind of loop. Now why I am passing inputs but why I'm not getting, I'm passing inputs, why I'm not getting, why I'm getting empty. So this is kind of a the gotcha you need to actually look out for. So just remove this. Okay, and or else what you will do, you can actually simply convert them here to list. Make sure you use map only. Make sure you use map only when you actually deal with very big data sets. Now, if I run this thing again, copy this thing, and paste it here. You see, there you go. Now it is working, right? So we are able to decode or not. See here, we can compare it with this one, input. Pick up, move right, move right, move right, drop, move left, pick up, drop, and quit. So next step, we are done with properly decoding a commands from integers to their method names. What you will do next, let's call those methods. Instead of actually calling this, we have the method equal to get attribute of self comma. What happens if you actually try to get attribute for, suppose here, class foo, and I don't put any attributes here, and I try to get attribute of I comma some count, I get the error. I get the error when you try to access. When you provide some default for a get attribute, that will be default value will be returned. But when you don't provide a tar argument, what you will get attribute error for referring to attribute which doesn't exist. So we got the method. Make sure that we are assuming that we get actually the inputs for a valid method sound. So I'm getting the method. Then let's call the method and run this thing again. The making sure now we get actually move left, move pick up, So to make sure actually, let's stop this one, stop this. what you will do to just, we will add a 3 dots, making sure, some kind of work is going on. So to actually indicate this is getting printed from these methods. So let's run this one. There you go. So it is working. We're able to call those methods. What we will do, and let's do the job. Let's do the job. What do we need to do? So move left means where current position is. See here, if the current stack has no boxes, just ignore. I think we would have to assume that it is actually starting from left only, because I don't find, so we are not even getting the input. We are getting the input N and then H, and then second line has those number of stacks. Third line has actually the sequence of commands. So initial, we can say initial position of the crane is above the leftmost stack, and the crane is not holding any box. Now this is, we would have to assume this one always, okay, because I don't find any condition here. So making sure crane is left. What we will do, move left means, is this having box? Let's add up a few more things. Self dot box equal to none, okay, because nothing. So the box crane is holding. Okay, self dot and position equal to 0. That is a starting position, right? So move left. Move left means if it is a starting position is 0. Okay. If self dot position, and so these are called state variables, or and they provide a state for our class object. So I'm referring self dot position is equal to 0, equal to 0. Just do nothing, return, because nothing to move left, right? So to just for us actually print nothing to done, just print that. Okay, later on we will remove all print statement. Okay, and move right. If self dot position greater than or equal to h self dot n, number of stacks, isn't it? N stands for n. Yeah, so the width of the game is n, which is a number of stacks. You see the boxes of the stack of boxes, which is n. Okay, self dot n, which is greater than, just nothing to do, print nothing to do, and pick up. So it has a box already, self dot box, print nothing to do, nothing to be done. What happened? Ah, sorry, I missed it. Okay, and drop if not box, print no box, no box, not holding box, box to drop. Hello. Let's run and paste. What is the first command here? Executing commands. First command is 3. 3 means pickup. And do we have function pickup? Yes, there is a pickup. And nothing to be done. Here it is printing. It is printing nothing to be done. Not holding box to drop. And nothing to be done. Nothing to be done. Not holding box to drop and quit. How many commands are there? Total. Yeah, these are all commands, right? Which is a, if we go to tar line, according to inputs, what is tar line? A sequence of integers, each encoding a command to the crane. So each one is actually describes the command to the crane. 3 2 2 2. 3 means that pick up, 2 means that move right, like that. So we wanted to check that which method is getting called. Put the print statement calling action for command dot format. What which is a method, and the what action which is CMD. If I rerun this and paste, and here we go. And we wanted to, we can verify here. So if the actions are actually, if they are being called properly or not. For the command 3, which should be called pickup. For command 2, move right, move right, move right. Okay, move right. Okay, and for command 4, just drop. And then have here, and then for command 1, which is, what is command 1? Move left. Yeah. So you can verify that properly all boxes are being called. Sorry, properly all actions are being called. All proper method is getting called. So now what is a goal here? What output here? What output is expected here? The output format. So what is sample output? Sample output, what it should return? It should return basically, after these actions are done, how many boxes are there in each stack? Okay, that is what here you can see here. So you have to compute the final number of boxes in each stack. That is what our goal is after all these actions are performed. So what I can do when these actions are being performed, I can note down. Okay, so I can note down If I pick up actually, and I need a flag, position flag. We have the position, and so I need the box, whether box we are holding it or not, and a stacks. Current position is 0, leftmost. Hmm? Starting position is 0. So move on. So it can't go actually the beyond 0, you know, because that is a starting position. So now what we will do here, when we pick it up, when we try to pick up, we are checking whether box is there or not. Okay, so not holding anything. What is first action again? Pickup is 3. First action is pickup, right? Yeah. So if we have a box already, we can't pick it up. So I wanted to log this thing. Holding box already, can't pick up. So it is meaningful. We can remove actually these messages and return. Nothing to done, right? When you return, the further code of the function will not be executed. So you are returning back to the caller, because when you have box already, you can't pick it up, so that you don't want to do anything, just return back. So the rest of code we write here, so that will be executed when you are not holding on to anything, if the crane is not holding on to anything. So when you pick up, take the position. What is the position? Current position 0, right? Self dot position, which is 0 already. So what you will do, you have stacks already. Stacks represents the number of boxes in each row. So from what we will do, self dot stack, and what position 0, which is self dot position. Since you are picking it up, put self dot box equal to true. You are holding on to the box. So this is a flag we are doing. So box means that whether you are holding on to box or not. So since I'm picking up, this is a pickup action. So I want to reduce that. You know that minus equal to, which is a compound operator, shorthand operator, which means the a plus 1 equal to, this is equivalent to a equal to a plus 1. This is called a shorthand or compound operator. So I can write simply this one equal to, again, access and minus 1. Instead of doing that, we can use compound operator, minus equal to 1. So because since we are picking it up, so I wanted to update status. How many boxes are there in that column, in that stack? And so next thing is move right. So position in the, if it is move right, all I need to do is, self dot position equal to +1, which is equivalent to self dot position equal to self dot position +1. So move right. So if it is a move left, crane is leftmost. Leftmost position. Nothing to be done. So making those log messages meaningful, and I to make sure that you return back. You don't return back, even though regardless of the at what position the crane is, this will be executed always. You can either return back, or else you can do what is called, you can put else. Either way it works. If you don't use else, all you do is actually self dot position minus equal to 1. This is one way you can code. So, and drop. When you drop, what you will do? When you drop, you want to actually self dot box equal to false, and self dot stacks of self dot position equal to, since you are dropping, you need to increment that by 1, right, in that position. So our stacks variable contains the second line of the input, whatever you see here, which represents number of boxes in each stack. So what we are doing, we are simply those number of boxes in each stack as numbers, we represented that as a list here, and simply we are updating that list. So after we are done with it, quit. So when we quit, we can do one thing. So in the output, we have to print the resulting number of boxes after this, after we performed all these operations. So what are the resulting boxes in each stack? That is what we wanted to print. So we can print this either after we are done with this, or at the time of the quit operation. During the quit, we can write some other function, print stack, print of stacks. So when last command, which is 0, is encountered, we are printing the stack and we're quitting. We can either do that at the last command, or we can do that same thing here and that in stack. So let's run this thing now and see what we have got. There is an error here in stack. So sequence expected string instance, sequence item 0 expected string instance int found. So when you get this error, if you are using IDE like a PyCharm or VS Code, if you click on that particular link, very last one, which indicates where the error is exactly, if you click on that one, you will be taken to directly that point, that position, where when you use any sequence with the join method, it expects actually string, sequence item 0 string expected int found. What you can do, it expects the string, but instead integers are there. We can actually use map, or we can use something like of I for I in self dot stack stacks. We can do that, or we can also do another thing, which is join map of still comma self dot stacks. We can also do that. Now try this thing if it works, or else if we get any other kind of error. Okay, worked. But is this answer, whatever which is printed at the end, is correct or not? We can validate against this output here. So we have this 2131, right? 2130 401, and we missed one thing. We almost, actually we are very close. 213, fine, but we have got one thing here, 0501. Why is this error here? 213, up until 213 we are actually right, but from thereafter 3 we actually got an error. So why? Because we haven't used what is called h here. To take it, two inputs we are using 7 and 4. What is 7 here? To look at the way, the input format, first is a width, number of stacks, and second is actually max height of the stack. Okay, h. And then integer and in the second line, which prints number of boxes in each stack, and then third line the operations. So what happens when you try to drop the box which has actually 4 boxes already? It should throw an error. So that is displayed here. See, for example, suppose the initial configuration of K is shown the figure stack 7 4 and H is 4. This is the one. Probably this is the one which explains that scenario. Further, there is a limit h of number of boxes on each stack. If a drop command would result in a stack having a more than h boxes, the crane ignores the drop command. Okay, so if you have 4 boxes already, and when you try to drop, crane should ignore that command, because the maximum height is h, which the particular stack reached already maximum height. The current stack has no boxes, pickup command should be ignored. But in our case, we are not actually checking that scenario. That is the reason we ended up with 5 here. And because that scenario is not actually tested, and that as a chain reaction, and we can see here, so that is actually carry forwarded, and we would see we can see that error actually carry forwarded to other positions. So, and we have in a pickup command, drop command, I need to actually, if no drop, I can rewrite this like this. Elif, if there is no box, just don't do anything, nothing to, not holding the box, not holding box to drop, not holding a box to drop, and Elif. So LFE is actually only any kind of, if else if ladder, only one block will be executed. If this condition is true, only it will be executed, and control will return back if it is a if else ladder, if else if ladder. So that is why I'm adding another condition. If self dot, I need to check self dot stacks of self dot position. If it is already greater than if it is having 4 already, do you get it? If it is having 4 already, it reached the limit. Sorry, it should be actually, it should not be hard coding that 4 is actually is the input, second value. So we have that stored here, self.h. So self.h. So I can call it, actually I can rename, we can use the IDE to rename this. Right click, go to refactor and rename. So all instances will be renamed. Instead of actually h, we can use actually max some meaningful name, max stack size. So since I rename this thing by using refactor, so wherever it is used, in that case also it will be renamed. You can see here, bang. So if it is actually less than 4, it's okay, but it is exactly equal to 4, nothing to be done. Okay. Stack has already so what is the stack position? I wanted to print something here, the position. Now format. So self.position, and then stack has already 4 boxes. This self.max size. And now else, if no those two conditions are not met, and execute this one. So if we rerun this thing, go here, copy and run. See if we have reached the yeah 2131401. Yes, it is finished. There you go. So we can see here in the output in an elegant manner. So we can see here the holding box already can't pick it up, and stack 4 has already. So which is a stack 4, in fact. This is the one. 1, 2, 3, 4. And 5. Okay. The index starts from 0. Probably, stack 4 means this one. Okay. If we count from 0, 0, 1, 2, 3, 4. This one has already 4 boxes. That is the reason. That is why it is saying stack 4 has already 4 boxes. So just ignore that command. If we actually run this thing, let's rerun this with the sample input 2. For rerun, paste that, and we should see 153. And there you go, 152. Yeah, so 153 means that we have done some mistake again, where crane at leftmost position, nothing to be done. Crane at leftmost position, nothing to be done. So we have done some mistake already somewhere when it comes to using probably picking up the box, either picking up the box, because we have actually already addressed drop. We have addressed the drop, so we haven't addressed the probably all scenarios when we pick up the box. Okay, and this is why actually testing is necessary. Do you get it? So because this is working with this input, this kind of input, and this is if this is not working with this, because when performing these operations we lost track somewhere. So you can see here the output, but the code is working fine, but we got the error a specific kind of input only, but other inputs it is working fine, which means that there is a logic error in the code. When we run this one, copy, it is actually working in a most elegant manner. Can remove, so just adding some new lines. Do you understand why testing is necessary? So for suppose, let me give you one example. ATM cash is dispensing. ATM machine is dispensing the cash. It is working all fine, but is not actually able to, when you enter some specific amount, okay, there's a logic error in the program during the calculation. It is dispensing more amount. Okay, so how do you find those scenarios with the extensive testing? So come here, let's take this input. We will see, we can figure out what kind of problem it is. Most probably what is you can get help from log messages. Stack 1 has already 5 boxes, so because check the input. Second one is a stack, right? So first one is actually the number of line input content, number of stacks of boxes, and second one is actually max height. 252. So number of stacks is 3, and number of boxes for stack is 5. So first one is having 2, second one is having 5, third one is having 2. Can you guess what could be the problem here? Per run for this input, it is working fine, but for this kind of input, it is not working. And instead of 1532, and we see an output 153. What could be the issue? So to figure out, either we can set the breakpoint here. We can set breakpoint, and we can debug instead of actually running. And select instead of run, can do debug. When the control reaches that particular point, what we will get uh, the program will not continue to execute. The program execution will be past their halter, so that we will get a chance to see through the correct execution stack of our variables and uh, local variables, global variables, and so how actually the flow goes through. So for that reason, we can do one thing. We can set print statements. Another thing, we can set a breakpoint. What I will do, I'll set the breakpoint. So how many operations So where do you want to really set a breakpoint? You can set a breakpoint, wherever you wanted to test, or wherever the in error is error might be wrong. There might be a logical error. You see, whatever we are getting here, there are different kinds of errors: syntax error, exceptions, and logical errors. What we got here, 153, it is supposed to be a 152. So this is not a syntax error. This is not an exception. This is a logical error. So because of a logic malform, so the way the code is written, the way logic is addressed, business logic, or so that there's a problem in that, which is a logical error. Figuring out logical errors is the most difficulty task. Whereas you can really, if there is an exception that will point you to the right location, you can solve it. Logical errors, solving them is quite hard. So what I'm doing, so I'm setting a breakpoint here. So I will run the, instead of running, so I, instead of just run, I've selected a debug. So copy this input, paste it here. And now immediately when it reached that point, you can see console here. A console, you can actually pick, you can really see what is output, what is being printed on the console right here in this tab. On debugger, you can see current state and call stack. So this is getting where this call stack displays. This drop function is called by this method, which is a call. The call is method called by main function. Call method is invoked by the main function. The main function invoked by this function call. So you can really see the chain of functions. This is called a stack. So function, you can see function call stack. You can see how which function is really responsible for invoking particular function. So now I wanted to, so what I wanted to do, this is what operation it is. I wanted to check self dot max size. You, whatever you wanted to watch, you can add those variables here. Self dot position. The position is 1 because we have moved already. Starting position, remember, starting position is 0. So one position is moved already. So we can actually, what we can do, we can step over. Since it has a box already, checking this, the position is actually the maximum size now. And yeah, it works fine. It went back. So I will also, we can actually on fly, we can set another breakpoint, any breakpoint anywhere. So I will, looking at this input, the how many, what is it? 1 means move left, 2 means move right. There are actually a lot of move rights. So I'm setting the breakpoint here. Now you can click on resume program. So program will continue to program execution will continue as usual until another breakpoint occurs. So whenever you encounter a breakpoint, you get a chance to actually console. In this console, you can actually do all sorts of magic, such as actually getting variables and doing some writing some expressions to compute any value. For suppose, what is the max size, what is current position, so which is 1, what is stack, uh, stacks, so which is 152 here we have already. So what I'm doing, so I will resume here, and there you go, we reached. So what position it is, since I'm watching these variables, I can see here position is 1, which means that we have executed move already. This is what we can see here, 3 2 2 2 2, right? And the position is 1, which means that since it is less than self dot n, so we can increment this. If we increment this, since we are incrementing, then go on, and then I reach this another operation, because this is move again, right? Next operation is, and now the what is the position 2? When position is 2, incrementing this by 1. So if I increment this by 1, if I go, if I'm watching at this self dot position, it is 3. There you go. So I found the error. What is the error here? Position. Position is not supposed to be 3 here. So why? Because how many here? So how many stacks are there? 3. And you may ask, you have actually 3 stacks. Position can be 3. No, because the stack we in our program stack starts from 0. Stack position. You see here, we count from 1, 1, 2, 3. But if we count from, yes, if you count from 0, index 0, 1, 2, because our last position would be 2. So we are not actually calculating counting those stacks. So because we stored these stacks as a list here, each stack is addressed starting from 0, which is an index, to n minus 1. So here we are doing some very blunder mistake, which is expected. I'm checking just against the position 3 while I'm indexing, counting from 0. I'm checking it as if I'm counting from 1, 1, 2, 3. So last position should be 2 if you are counting from 0, 0, 1, 2, not 3. But of course it is 3 if we count from 1, 1, 2, 3. So I can stop this. How to stop this one? Here, stop debug. And since we are after we are done with debugging, we can run this again. Now copy input from here, paste it here, and there you go. So we got 5152. If we try this input, uh, we change. This is called regression. If you print if you fix something, if it is causing some other error, that is regression. But there is no regression here, which is output is 213 1401. It works fine. So if you don't want, actually all you can do is remove these print statements. There you go, you are good to go. You don't want all other print statements as well. I'm keeping just those couple of print statements. We run this. There you go. And our output. And here is the code. Pretty much code is taking the input, and we defined our range class and we define those commands against names of those methods. When we actually created this class, we initialized that instance with the default data, and then when that instance is called, we are invoking that method. We can name it method instead of methods, and here you go, and move right. And as we actually make these actions, we're storing them in stacks the position. And then finally we are printing. Rerun this, final rerun. There you go, 2131401. Happy coding. Goodbye.